Hello, welcome to 5.3, Logarithmic Functions and their Graphs. So logarithmic functions, let a be a fixed positive real number, not equal to 1. The logarithmic function with base a is defined to be the inverse of the exponential function with base a, and is denoted by log base a of x. In symbols, if f of x equals a to the x, then f inverse of x would be log base a of x. It'll undo what the exponential function just did. So another way to think of it is this. Y equals log base a of x would be like saying, okay, a to what power makes x? A to the y equals x. So this exponential and this logarithmic equation, these are very related. That y says, okay, a to what power makes x? The answer is y, because a to the y makes x. These are equivalent statements. So a is the base in both equations, and this is a lower subscript. This is not saying a to the x here. This is saying log base a of x. Either the base of the exponential function or the base of the logarithmic function, that's our a. Now I want to stress in your calculator, if you have the TI-89 or TI-83 or 84, it has two log bases, log base E and log base 10. If you have like the TI-Inspire or the TI-Inspire CAS, you can put whatever you want for the base. That's a new thing with those calculators, kind of a nice tool to have. But we don't need that. We can get around that with some other relationships we have. Okay. Recall the graphs, let me scroll this up a little bit, of a function and its inverse are reflections of one another with respect to the line y equals x. Since exponential functions come in two forms, a between 0 and 1 and a bigger than 1, logarithmic functions fall into two similar categories. So here's f of x equals 2 to the x, here's f of x equals log base 2 of x, and they are reflected across the line y equals x. Here is f of x equals 1/3 to the x. F of x equals log base 1/3 of x. And this doesn't really look like it as much, but they are reflected across that line y equals x. So we're going to sketch the graph of the following functions. For example, 1. So sketch the graph of the following functions. G of x equals log base 5 of x plus 2 minus 1. Let's have a column for x. We'll have a column for x plus 2. We'll have a column for log base 5 of x plus 2, and a column for log base 5 of x plus 2 minus 1. Now what I'm going to go with in this column here, get these values and then go back to get these values by subtracting 2. Why go for this column first? Because I want to put things in here that are going to be 5 to a power. For example, 1. Log base 5 of 1 is going to be 0. I can go with 5. Log base 5 of 5. 5 to what power makes 5? 5 to the 1 power. How about another thing? 25. Okay, it's going to be beyond our graph there. 5 to what power makes 25? 5 to the 2 power. How about 1/5? 5 to what power makes 1/5? 5 to the negative 1. How about 1/25? 5 to what power makes 1/25? That's going to be negative 2. Then over here we subtract 1 from each of these. We still need our x column though. Subtracting 2 from each of these. This is x plus 2, this is x. So 1 minus 2 is going to be negative 1. 5 minus 2 is going to be positive 3. 25 minus 2 is going to be 23. That's going to be beyond our graph. 1/5 minus 2 is going to be negative 1 4/5. 1/25 minus 2 is going to be negative 1 24/25. Okay, so let's go ahead and graph this. So -1 for x corresponds to -1 for y. 3 for x corresponds to 5 for y. No, to 0 for y. This column and this column. 23 is not going to show up. -1 and 4/5 corresponds to -2. And then -1 and 24/25 is going to correspond to -3. And there's our graph. This line, -2, x equals -2, is an asymptote. It's approaching that. Okay, I'm going to go to the next problem. Feel free to pause this. Next one, s of x equals log base 1/3 of 5 minus x. So let's do our column of x. Our 5 minus x column. And our log base 1/3 of 5 minus x. Now I'm thinking of, now 1/3 is 3 to the -1. So we're talking about 3 being raised to a power. So think about those kind of answers. For example, something that I would plug in here, 1/3 of what power makes 1/3? Well, 1/3 of the 1 makes 1/3. 1/3 to the what power makes 1/9? Well, 1/3 of the 2 makes 1/9. How about 1? 1/3 to the 0 makes 1. How about 3? 1/3 of the -1 makes 3. How about 9? 1/3 of the -2 makes 9. Then we'll go back here. This is 5 minus x, so this column would be what? If 5 minus x is 1/3, negative x is -5 plus 1/3, x would be 5 minus 1/3. So this is 4 and 2/3. So 5 minus there, you're going to have 4 and 8/9. 5 minus 1 is 4. 5 minus 3 is 2. 5 minus 9 is -4. Let's try plotting this. So x being 4 and 2/9, 2/3, corresponds to 1. X being 4 and 8/9 corresponds to 2. X being 4 these off. 4 and 2/3 is 1. 4 and 8/9 is 2. 4 corresponds to 0. 2 for x corresponds to -1. And -4 for x corresponds to -2. And that's that. And note, log base a of 1 is 0 because a to the 0 is 1. Log base a of a is 1 because a to the 1 is a. And we're saying a to what power makes that? A to what power makes that? Log, this should say base a of a to the x. Well, a to what power makes a to the x? That's just x. Also cancels itself out. Also, a to the log base a of x is x. Let's go ahead and go on to this last part of this page. It says evaluate the following logarithmic expressions without the use of a calculator. Log base 1/2 of 4. This is saying 1/2 to what power makes 4? Okay, what power would that be? This is like saying 1/2 to what power makes 2 to the 2. Well, 1/2 is 2 to the negative 1 to some power makes 2 to the 2. So it's negative 1 times something makes 2. Well, that something must be negative 2. So it's 1/2 to the negative 2 power. So this answer is negative 2. How about B? Log base 3 of 27. 3 to what power makes 27? Well, 3 to the 3 makes 27. Now we have log base 3 of log base 27 of 3. Okay, so 27 to what power makes 3? This might be helpful to see this as 27 is 3 to the 3rd power. Being raised to some power will become 3 to the 1 power. So it's 3 to the 3 times some power equals 3 to the 1. So 3 times some power equals 1. So that power must be 1/3. An empty box. So we're saying log base 3 of 1/3 is what? 3 to what power is 1/3? Well, that must be negative 1. Our power is negative 1 in this case. And finally, 3 to what power makes 1? Well, 3 to the 0 power is 1. Let's go on to example 3. Let's scroll this up, so feel free to pause. Okay, use elementary properties of logarithms to solve the following equation. Log base 16 of x equals negative 3/4. This is saying 16 to the negative 3/4 equals x. So x equals what? 1 over 16 to the 3/4. That's going to be equal to 1 over the 4th root of 16 raised to the 3rd power. It's 1 over 2 to the 3rd, which is 1 over 8. B, log base 1/3 of 3x equals 2. This means 1/3, this base, to that power, to the 2 equals 3x. So 1/9 equals 3x. Dividing both sides by 3, x equals 1 over 27. Next one, log base a of a to the log base b of 5 equals 0. Well, log base a of a to a power, that just cancels, which means log base b of 5 equals 0. That means b to the 0 equals 5. Oh, that's an s. I'm sorry, that's not a 5. That is an s. Well, anything to the 0 power besides 0 is going to be 1, so 1 equals s. Okay, I'm going to move this up. Feel free to pause that. The function log base 10 of x is called the common log, and it's usually written as just log with nothing down there. And that's on the calculator, most calculators. The function log base e of x is called the natural logarithm. This is the most commonly used one. This is very popular. It's seen on the calculator with an ln. I know natural log should be nl, but they do ln of x. So just be aware of that. And this is the one that you're going to find readily available on your calculator main screen probably. Properties of natural logarithms. Natural log of x is equivalent to saying e to the y equals x. I should say y equals natural log of x. Natural log of 1 is 0. Natural log of e is 1 because e to the 1 is 1. E to the 1 is e. Natural log of e to the x is x, and e to the natural log of x is x. Okay, our last page from this section. Solve the following logarithmic equations using the calculator if necessary to evaluate the logarithms. Natural log of x plus 1 equals 3. Okay, we want to undo that. So we'd say e to the natural log of x plus 1 equals e to the 3. By doing this, e and the natural log cancel out, and that gives us x plus 1 equals e to the 3. Subtracting 1 from both sides, x equals e to the 3 minus 1. That's the exact value. The decimal approximation would be 19.0855. The next one should read the natural log of e to the x equals 5.6. Well, natural log and e to the x just cancel. Leaves an x. Natural log and e to a power leaves that power as 5.6. Okay, the next one, I'm going to scroll this up just a tad. Give us a little more space down here. This is log base 300 of log x, common log of 300 to the power log, common log of x equals 9. Now, I didn't state this yet. This is a property learned in the next section. This power can come out front. So we have common log of x times common log of 300 equals 9. Now, common log of 300 is just a number. It's just a coefficient. So if you have common log of x times common log of 300 equals 9, you can divide both sides by the common log of 300. That's something you can just get from your calculator if you wanted. That divides out. So common log of x is 9 over common log of 300. Now common log has a base of what? What's the base for common log? We talked about that in the previous page. You're right, 10. So you could say 10 to the common log of x equals 10 to the 9 over common log of 300. So x equals 10 to the power of 9 divided by common log of 300. And that's going to give us approximately 4297.83. The exact value of the approximation. I'm going to go to the last problem here. Two problems, last two problems. Let's write the following equation in logarithmic terms. Okay, there's our base. So it's going to be log base x of 27 equals 3. Log base of what number gives us the power? Next one, write the following in exponential form. Here's your base. Your base to that power makes this number. So b to the 1/2 equals 4. And that does it for section 5.3. So hope you enjoyed that. Send me your questions. Thank you.